In space, mass determines a lot about how a celestial body behaves. The reason we don't have asteroid-massed stars or star-massed asteroids is because mass is an inherent factor of what makes a celestial body what it is. As size increases, so does gravity. Gravity can be simplified as mass divided by radius squared. Celestial bodies are three-dimensional shapes, which means that their mass generally increases with radius cubed. If the radius is doubled, the mass is multiplied by 8, but only needs to be divided by 4 in our simplified equation for gravity. As size increases, an object's self-gravity will start to exert different pressures and different forces, giving these categories of size different characteristics. We start with the smallest category, non-spherical objects. These range from asteroids to comets to small moons. They are so small that they barely have any gravity. Even one of the largest in this category, Vesta, has a surface gravity 40 times less than that of Earth's. For some of the smaller of these objects, you'd have to attach yourself on or else you might float away. The upper limit of this category is when something starts to pull itself into a sphere. Small objects have the liberty of being in any shape they want because their gravity isn't putting pressure on themselves. Larger objects, though, can be so massive that their gravity exerts pressure on them. If this happens, your non-spherical object has become a dwarf planet. A dwarf planet has enough mass to make it a sphere, but not enough to clear out its orbit. Large objects have enough gravitational influence to push other objects out of their orbit by destabilizing them. Anything ahead of these objects would get pulled back and slowed down. This would cause them to fall into a lower orbit. Anything behind would get pulled on from the front, which would speed them up and bring them into a higher orbit. Either way, the orbit gets cleared. Dwarf planets, while large enough to be spheres, are not large enough to push other objects out of their way. By the way, that's why Pluto is not a planet. The largest dwarf planets have a little under 1/10 of Earth's surface gravity. Not a lot, but not the zero gravity that you'd have on an asteroid. When a dwarf planet gets big enough to clear its orbit, it graduates to the level of terrestrial planet. Terrestrial planets are like Mercury, Venus, Earth, and Mars. These are rocky planets with Earth-like gravity. They range in mass from similar to Mercury to just under 10 times Earth. If a planet gets bigger than 10 Earth masses, it has the ability to hold onto a lot of gas, even the lighter ones like hydrogen that are easy to lose. With over 10 Earth masses, there is enough gravity to pull in interplanetary gas and keep it from getting blown away by solar wind. Once this happens, a snowball effect makes the planet mostly gas with a rocky core of its former self. This is the category gas giant. Jupiter, Saturn, Uranus, and Neptune are gas giants. Gas giants are planets made of mostly gas. They are between the mass of 10 Earths and 13 Jupiters. Over the mass of 13 Jupiters, there is so much pressure on the planet's core that a material called deuterium is able to go nuclear fusion. Deuterium is like hydrogen, but it has an extra neutron. This material is easier to fuse than hydrogen, so when gas giants get big enough, they fuse deuterium first. This category is called brown dwarfs. Brown dwarfs range from the masses of 13 Jupiters to 80 Jupiters. These objects are not quite stars because they only temporarily fuse deuterium, and the bigger ones can momentarily fuse hydrogen. Once a brown dwarf gets large enough, however, there is enough pressure on it to completely fuse hydrogen into helium and sustain this reaction. Once that happens, the object is now the category of star. To recap, as they get bigger, objects become spherical objects because of their gravity. Then they can clear out their orbits because of gravity. Then they can accrete a large amount of gas because of their gravity. After that, they can temporarily fuse some of that gas because of gravity. Finally, they can completely sustain a fusion reaction because of their gravity. In conclusion, the scaling up of objects makes the force of gravity increase. This increase of gravity is what shapes them and gives them their distinct characteristics.